Hey, George, you're a scientist.
I'm a chemist, yes.
Right, you're a scientist. So, why can dogs smell better than people? Like, not why does the dog, like, is a more pleasing scent? I mean, like, why are they able to smell things better than, like, I could smell things?
Lions, I'm a chemist, not an evolutionary biologist, but with my very limited knowledge and very limited expertise, if I had to venture a guess, I think that the first thing we would need to talk about is why things. No, or to be more specific,
That is starting at the beginning.
why things. So the first thing basically was that the universe is inherently at its core a very boring place because of entropy, right? The universe doesn't like to be interesting; it likes to be boring. In order to do interesting things, it needs energy, right? So what you need to do is take energy from one place and plug it in somewhere else. And so basically, life on Earth was kind of just chugging around, doing its thing, right? And then somebody said, "Hey, there's a big old ball of fire in the sky. What if I could eat that energy?" And then evolution said, "Yeah,
Yeah.
I'll help you out with that." And bam, photosynthesis. They were able to take sun energy and change it into ATP, right? And then everything was cool for like several billion years. Everything was kosher, right? But then all of a sudden somebody said, "I don't know, man, getting all of this energy from the sun, that's a lot of work. Hey, buddy, you've got energy, right? How about you give me some of your energy?" And they said, "No, this energy is from me. You see, I got it from the sun." They said, "Nah, I'm going to take it." And so then they ate that person, right? And so thus animal cells were born. So basically animals said, screw all that photosynthesizing. I'm going to eat other people's. It's like you had ATP and I didn't have ATP. And I had this proboscis. See, here's my proboscis. And I've reached across the room. I certainly mispronounced that, but anyways, then the big question was who can steal ATP the best, right? And so
This is just all the sun is up there radiating energy down. And instead of saying, let's all develop photosynthesis, because there's a functionally unlimited amount of energy coming from the sky god, it was, I don't want to develop photosynthesis because I'm lazy, so I'm going to develop teeth.
Yep, pretty much, right? I'm going to put all of my evolution points into teeth, right? The other upside, though, is that, making photosynthesis, right, it doesn't give you a ton of energy, but you can eat things way faster, so you can do more cool stuff. If you just took 10 cells that were photosynthesizing and you say, okay, but now all for George,
So instead of developing gigantic solar arrays, like we're not all just big solar array animals like
right.
that. It's a density thing. Like it's a transfer thing.
Yeah, exactly. Right. Instead of having a ton of solar cells, instead I just, ate a person. So sorry, I kind of lost the thread there. Anyways.
No, that sounded right.
Instead of using a bunch of solar arrays to power a hydroponic farm, I'm just eating people. So I say all that to say that then the thing is that what determines whether or not you're successful or whether or not I'm successful, right, is who can eat cells the fastest, right? And so in order to do that, the best way is to develop senses. So senses developed in a particular, we believe, in a particular order. Which one do you think we got first?
Ooh, I mean, am I extrapolating just from human senses? So like sight, sound, touch.
Yeah, the big five.
Yeah,
we'll stick with the big five.
Not like a sense of time or looming dread. Like not those came later.
Or a sense of humor. No.
Yeah, no, I'm still waiting to develop that one.
To be fair, my sense of humor has gotten me more food than my sense of hearing.
That's probably maybe.
Yeah.
But not your sense of foreboding. I would say maybe.
Why would you say that? What's about to happen?
I would say maybe like what you would, I guess, colloquially call sight. So like light sensitivity, because if we already were developing some specialized cells for working with light in photosynthesis life, not we humans, we life, we're already developing some specialized cells for interacting with light, then maybe that was like a small mutation as opposed to like a massive mutation.
See, that's a good guess. The first one would be touch, because
Oh, so
in order to eat something, you got to touch it.
Yeah. So so you had to have some way to recognize that there was food in your environment.
Correct.
And we did it by colliding with food.
Basically, when we touched food, we were like, food.
Food.
And then we just put that food in us, So the pros is that when you touch something, you're close enough to eat it, right? So that's good. The downside is it's close enough to eat you. So, not great, right? So what we then needed was like kind of a way, it's like, okay, if I'm going to go eat something, right? And especially, or if it's about to eat me, what if I were to eat this thing and it kills me from the inside, right? Like if I'm the Tarrasque and I eat a person, I need to make sure that they're a nice, soft, pudgy villager, not a level 15 rogue that can sneak attack me from the inside, which rules are still open for debate on that one. But anyways. So then the next thing we discussed, we evolved was a sense of taste, right? So when you think about a sense of taste, what do you think of? You think of like things that taste good or taste bad, right? Something like that.
Yeah, I mean, in a like the most rudimentary sense, I would think of this is a thing I can eat versus this is a thing I can't eat, right? Presuming that there are things in the universe that are not food.
Correct. Right. So when you try to eat a table, you're like, this doesn't taste good. But when you eat delicious meat or, like even vegetables or whatever, you're like, this does taste good. Or if you eat something that tastes, really repugnant, you spit it out immediately and this tastes terrible. So what's actually happening is that you have chemical receptors that are saying, there's this chemical. And this chemical is a chemical that I want to put in me. Please continue to do what you're doing. Or this is a chemical I don't want to put in me. Please stop. Which is why, things that have kind of like a bitter taste, we tend to not like, because a lot of times things that are bitter are very alkaline, which would be bad for us, right? But basically all taste is touch, but for chemistry,
Ooh, I like that. It's touch for chemistry. That's a bumper sticker for sure.
Yeah, so basically, as we said, okay, if I can touch it, then I can eat it. But also, is the thing I'm going to eat, am I going to die? Is it going to kill me? So again, the upside is that, as I said, is that, so the upside to taste is that, you're not touching it. The downside is you're absolutely touching it, right? Like you still have to be really close to it, right? So then it's like, okay, so what if, hypothetically, I wanted to determine if I could eat a thing before I got super close to it? And that's where sight comes in, right? So initially, sight was just being able to see the presence or being able to register the presence or absence of photons, right?
Right.
But that's all it is.
Super blobby shapes, right? Like people with crappy
not even
vision.
that.
Yeah.
It's just light or no light. It was on off.
Oh, super binary.
Yeah. It was like there is light, there is no light. Because if there is no light, then chances are there's something near you that has blocked the light, and you kind of need to be aware of that.
So you can eat it.
Yes, or run away from it. Depends on how much light it's blocking, right? But finally, we had a sense that did not require us to be touching something, which was, really, really clutch. Which then started the sight arms race, right? So now all of a sudden, to your point, right? Before it was like light, no light, and it's like, but I can kind of see fuzzy light. It's like, well, I can see super clear light. It's like, oh, well, I can suddenly make out, the fact that, oh, well, this thing has certain colors associated with it. And when that thing has a certain color, it'll kill me because, the reds indicate that it has a certain, type of chemical in it that I don't want to eat. And then other things said, well, I'm just going to have the red pigment and not actually have the chemical because having the chemical is time consuming. I don't want to make that chemical. So then after all of that, we would have what we would ostensibly call smell, right? And the reason why smell comes so much later is because kind of the way we've defined it, right? Which is that smell is taste, but in the air, right?
Yeah, it's like sample chemistry.
Yeah, well, it is, but I mean, if you think about it, right? Like, so we say like, oh, sharks can smell from blood for 1 billion miles away, whatever people say, right? It's like, well, yeah, it's because it's kind of going through that organ, but it's really closer to tasting it, right? Like, what's the difference between it going in through their mouth or going in through their nose, right? They're functionally isn't a large one, right? And again, I do feel the need to stress again that I'm a chemist, not a biologist. But but I say all that though to say that, you know, from my understanding is that we really define smell is being able to bring in chemicals that are carried by air, you know? Which
So,
again,
does that mean there wasn't? Would you still consider it smell if it was in the water? Like, is what a shark's?
no, I would not.
They're tasting. They're
I
what we
would
would
argue that
consider
they're
tasting.
Yeah.
Oh my God. I'm not high, but this feels like what being, because we absolutely use that word to refer to what animals in the water are doing.
Right. And that's the thing is and I think that you could make the argument if like, oh, well, if it goes through the pathway that then goes to the organ that they use to distill oxygen out of the water, then like if it goes through like, you know, their gills or whatever, then like, oh, well, that's smell and that's this. But from what I could kind of, you know, from what is my knowledge and from what I was able to discern is that smell is kind of defined as, no, it's not carried through liquid, it's carried through the air. Now, you can taste things that, you know, are carried through the air, but the idea is that it touches the liquid on your tongue and is then like back into a liquid matrix, you know? So then the nice thing for smell is it's you know, not ingested, right? That's pretty nice, is that like you can kind of bring it into your body and then push it back out, right? And then finally, the last thing that we got was hearing, you know, where hearing is kind of clutch because one is it does require, you know, for you to be kind of, it gives you a low amount of information, but the nice thing is it's 360 degrees, right? So you don't have to like have eyes in every direction because that's super cerebrally intensive. You need a big computer to deal with all of that information. You don't need as big of a computer to deal with hearing, you know? So I say all that to say, why do dogs smell better than people, right?
Yes. Now that we've invented the universe, let's bake our apple pie.
Exactly. Yes. It's a good analogy. I'm sure a very handsome man came up with that.
He did.
So I say all that to say that basically with smell is that with any of these senses, right, or any evolutionary advantage, it's just where do you want to spend your action points, right? So do you want to be really good at smell? Then what you would want to do is just create. So if smell, all it is just chemical receptors that certain chemicals hit and then tell your brain what there is to do, then dogs have just spent more evolution points developing that in two ways. One is that they tend to have like they just have more sense chemical receptors in their noses and what have you to detect to a lower degree. And just like in chemistry, is that like I can have like the lowest detector in the world, but if it doesn't have the computer to back it up, then it's no good. So they actually have a larger brain as well or that part of their brain that parses olfactory information is much larger, so they can actually process all of that information that they are getting.
Okay, so here's what blows my mind about this, and this actually has less to do with dogs and more to do with me realizing I live in the same world that dogs live in, which is like, if I'm out in front of my home and there's a dog and there's me and the dog goes like, "Arr!" and notices that like across the street, right, like a block away where the dog can't even see, there's a rabbit, right? So let's discount hearing, right? But
sure.
that means that the dog smelled that prey, right? If I'm standing next to the dog, that means whatever chemicals are coming off of the rabbit that the dog can smell are also washing over me, and I'm just not detecting them.
Yep. You are nose deaf to them.
So if there's... Okay, like when you look at something and it's like, oh, this is what the sun looks like in X-rays. This is what it looks like in radio waves. Could you do that for like chemicals in the air? Like, is there an overlay of here are all the smells you're not smelling that the dog is smelling?
That's interesting. You could do. We can do anything given enough money. So short answer, yeah. I mean, like if you just had a very, very sophisticated chemical scanner, right? Then you could say like, all right. And the thing is that it probably wouldn't be great for, immediate like live feedback. Basically you'd have to take in all the information from several different sources and then, visually repopulate it. But absolutely, and one could definitely make the argument that the amount of space living organisms' brains spend on each of the senses 100% colors their universe. And somebody once said to me that I found fascinating and 100% agree with, which would be, we would not have done the damage to the earth that we have done if we smelled like dogs smell. Because the world smells pretty acrid to them, kind of all the time, because of what we've done to it, you know?
Horrifying.
Yeah.
Yeah.
So
yeah.
breathe that in.
Yeah. That reminds me of when, was it the like 2018 Olympics or whatever, where like Beijing literally used fans to blow the yellow cloud of death like off of the city. Like, and that's like, I mean, clever, great, incredible feat of engineering, but like maybe don't live in a noxious cloud of sadness.
Yeah, right. And I mean, it would be kind of similar to, because again, like, you know, we kind of get, you can get used to anything, right? But it would be very similar to if, when you go into Beijing or any smog or polluted area, right? It would be kind of like walking into a room with hundreds of very bright strobing lights, you know? It would take you a lot of time to eventually you get used to it, right? But it would take you a lot of time to get used to it, and B, your sight would be worse in that room, you know, and potentially forever, right? But yeah, I mean, like, you would kind of just be like, whoa, okay. And then if all of a sudden somebody's like, dude, you didn't notice the guy in the gorilla suit walking around? It's like, dude, I could barely notice anything, man. It's really bright in here, and I'm getting a lot of weird signals and kind of all the time, right? So yeah, I mean, that's kind of what we've done to some animals that focus more on that particular sense. And actually, this isn't always the case, but there's some situations called evolutionary rescue, where rapid evolution happens in order to save, like, for a species to get saved, because we have so dramatically changed the environment that they're in, that it so aggressively pushes one particular type of trait or variant that it continues to survive, but now all of a sudden it doesn't like do a certain thing anymore. I believe that I want to say that pigeons were an example of this, but I've forgotten what it was that caused them to.
That actually does sound kind of familiar. And I think it was urbanization. Like,
it was urbanization that did it. I've forgotten how it changed them.
Yeah,
you know, like what traits they took on or dropped, because, you know, they were like, hey, we don't. Or it's like the Great Family Guy skit where, you know, it's all the seagulls talking to each other, and one of them says, you know, yeah, so we're gonna go and find a fishing boat and take all their fish, and one guy says, hey, so I was just thinking maybe we could not be annoying and just get our own fish. Can I talk to you for a minute? What are you thinking? What are you doing out there, huh? You gonna go catch a fish? What, with your clawed feet? Huh? You got clawed feet? No, you got webbed feet. No, I just thought. Oh, you thought, did you? Well, how's that working out for you? Not great. Not great.
So, I because you're a scientist, I'm confident you can answer this question accurately.
Sure. I can answer all of the questions. I'm a scientist.
Exactly. So I'm thinking about how this manifests in like macro scale behaviors, right? So when the dog, or, you know, the wolf before that, is out hunting, if they're doing long range chemistry by, you know, using their powerful, is it that they have more powerful receptors or more of them? Both? Just
more of them. Okay. So it makes it easier for them to distinguish signal to noise, basically.
Okay. Is this is there a direct correlation here on like the amount of rods and cones we have in our eyes process more light?
I believe so, but I you know, just a chemist.
Yeah, no. we'll say yes. So this is where they must have subconsciously or consciously developed a habit of like, oh, you need to be, would the expression be upwind, right? So you need to be where the scent of the animal can be picked up, right?
So that's downwind. So if you're downwind of the source, then you are where like the wind is blowing the smell towards you.
Okay, yes.
Yeah.
So like, you remember in like Metal Gear Solid or like in a lot of stealth games, there's like a vision cone. Like, I'm imagining that for like particulate matter in the air now, right? Is like, you are undetectable until the animal with the powerful olfactory senses has gotten into your like smell cone. And then they can do their long range chemistry with their powerful noses, and then they know. And I'm assuming this actually probably works in a similar way. Like the more intense the smell is my brain, if I'm this wolf, like can I then do like triangulation? Like I know they're over here or they're vaguely in that direction, similar to the way you would triangulate something like by sound.
What you can definitely do is a warmer, colder, right? You know, just like we do when we play find the cheese stick that my kid hid in the room 5 days ago. You know, like we can do it. That's the adult version of warmer, colder. You know, so they can do stuff like that, right? But I would probably argue that they can't quite perfectly triangulate. You know, like in the same way that like do you know, interestingly, like how we're able to triangulate sound, like where sound's coming from?
I think it has to do with our ability to process like intensity and timing. So like if I hear like if I'm in a square room and I hear something off to my left, it's because I got more intense sound sooner than the reflection off of the wall to my right. And so my brain is able to say like, oh, that thing the sound must have originated from here because of when I got these different signals.
Right. So it's more about the timing and less about the intensity. But yes, is it when, if you snap your fingers out, 45 degrees off to the right, is it'll hit your right ear slightly faster than it'll hit your left ear. And your brain says, I know where that is. A great way to test that experiment is wrapping a metal rod underneath water. It sounds like it's coming from everywhere because sound travels faster in water than it does on air. So it screws with that sense, right?
Yeah.
So I can't think of a way that, because of just the way that the dog's nose is set up, that they would be able to get that similar triangulation,
So you're saying we need to evolve a dog with a left and right nose.
I'm saying we don't need to do that.
Come on, man. Where's your sense of adventure?
In the dog's stomach with me.
Which, okay, that actually reminds me of another thing I want to ask you.